And this is the Koya SS GUI. This is where we're gonna be spending a lot of time. And it is an amazing piece of software where you can train the Dream Booth, LoRa, text to inversion, fine-tuning, etc, etc. It is really an amazing software. But before we start the LoRa training, we actually need to do the most crucial part of this entire operation, which is dataset preparation, or more simply, just finding good images. And if you are planning on training a character other than yourself, you can of course use Google Images, where you're gonna type the name of your character, like let's say I want to search for Margot Robbie, and then I'm gonna search the best images for that character. Now the secret here is of course to select the best images that are of high resolution and with a lot of variation. I'm talking about different backgrounds, different expressions, different angles, etc, etc. But the most crucial part is that every image needs to be of very high resolution. And for this you can either go here, click on Tools, then click on Size and select Large, and then it will automatically select a bunch of high resolution images, but where you don't exactly have the control over how high the resolution is. So what you can do instead, and what I personally recommend, is to use the Google's Advanced Image Search, which will basically give you way more control over the resolution of the images that you're trying to search. So for example, here I'm gonna input Margot Robbie, and then here in image size, I'm gonna have way more choices of resolution to choose from, where I can even choose images that are larger than 70 megapixels. So now if I select like this option, and I click on Advanced Search, it will give you the highest resolution possible of that character online. Now obviously 70 megapixel is way too much, so I highly recommend choosing larger than 4 megapixel instead, which will definitely give you way more options to choose from. But again, make sure that you choose good images that are representative of the character, and try to avoid out of focus or blurry images, or images where there are multiple characters. We only want one character and our character only. And basically just make sure that the image is sharp and crisp before you download it onto your computer. And if you're asking how many images do you really need, my advice for you if you are really lazy is minimum 10 images. I made some really fantastic models with only 10 images for the training. So yeah, you really don't need much. Now for those of you who are experienced in LoRa training, or for those of you who already did some LoRa training before, you might think that the next step would be image cropping, right? Where you basically use a website like berm.net to crop your images in a square of 1024 by 1024 resolution, right? Well, actually, you are completely wrong. That's right. Because in reality, you don't need to crop your images at all. Actually, quite the contrary. Because in my own testing, models created with uncropped images perform better each time than the cropped version. They created model with better resemblance and more flexibility. So really the bottom line is, just make sure that each one of your images is of super high resolution, and there will be no need for cropping. And later in the video I'm gonna show you why. So after we've saved our images and not cropping them, we can now go to the next phase, which is Stable Diffusion XL that looks like her. So how exactly do we do that? Well, for this we're going to be using a website called Star by Face, where you basically upload a picture of yourself or the character that you want to train, which it will then analyze and give you the name of the closest celebrity that looks like you. And as you can see right here, one of the person that looks like Millie Alcock is a woman called Sasha Luss, which I mean, I guess a little bit, but even if they don't exactly look like each other, it's not important, because what's important is that if Stable Diffusion XL knows who that person is. Because now if I search for Sasha Luss, lo and behold, Stable Diffusion XL knows who that person is, meaning that we can use that name for our instance prompt. So basically yes, in our case, if we want to create a LoRa of Millie Alcock, we will have to use Sasha Luss in the prompt. So when you're creating a LoRa, make sure that you input that name into the name of the actual LoRa, or else you will probably forget. So yeah, basically TLDR for the instance prompt, do not use the rare token, always use the name of a celebrity that looks like the character you're trying to train. Simple as that. So for the class prompt, here you're gonna input who your character is. Is it a person? Is it a woman? Is it a man? Is it an object? Is it a style? Is it a dog? A cat? Etc, etc. So in my case, since Millie Alcock is a woman, for the class prompt, I'm gonna input woman. So here you're gonna input the directory for the training images. For this, I'm gonna click on this little icon, then select my image folder, and here it's gonna ask you to select the folder for your regularization images. Now, regularization images are basically a bunch of images that correspond to your class prompt that are basically used to avoid overfitting and class preservation. Now it's a little complicated to explain, but basically it will make the model more flexible and more precise. And they're always linked to the class prompt that you're trying to train. And for the regularization images, you not only need to have a bunch of them, but they also need to be of very high quality. So for this, you can either find them yourself online. Since we are training a woman with the class prompt woman, we're gonna choose the 1024 by 1024 resolution of the 1000 woman images that for me are located right here. So then here you will see the repeats option. This is basically how many passes each training images will receive. But this is very easy, to not be afraid. For the repeats, the number that I always use is 20. This is really not the most important part because the most important training parameters will come later. And then here for the destination training directory, you will choose where the new folder structure will be created. So in my case, I think I'm gonna create it right here. And then you're gonna click on prepare training data. And now if you go to this folder location, you will see that we have now 4 brand new folders: image, log, model, and reg. If you go to inside the image folder, you will see another folder inside called 20 underscore Sasha Loss Woman. And what this basically means is that this 20 is the amount of repeats each image will receive with our instance prompt, Sasha Lush, and the woman as our class prompt. And these parameters will basically be read inside the training in the Koya SS GUI. And now what you need to do is just click on copy info to folders tab. And now that this is done, if you go back to training and then click on folders, you will see that before we had nothing, but now each section is populated with the location of our training folder. And the only thing that you really need to change is the name of our model output. So what I recommend you to do is first to input the name of the character that you're trying to train. So in my case, it will be Mealy underscore Alcock, and then create a dash with the name of our instance prompt so that we never forget what name that we need to use. So in our case, it was Sasha Loss. So then this way, when this will be in our database, in our collection of LoRA, we know what character we're looking for, and then we know what name we need to use inside our prompt, so that there's basically no way to forget. And then when this is done, you're gonna click on parameters. And here you will see a bunch of options. But don't worry, because as I said previously, because we input here our configuration file that you will find on my Patreon, everything is already done for you. You literally don't have to do anything. But before I go and explain all the important parameters, there is something that we need to do first, and that is image captioning. Now, image captioning is basically creating a new text document for each image where you're gonna describe the image. And the reason we do that is that caption helps the model understand what you're trying to train, which in the end makes the model way more flexible. Now, technically, if you're training a simple character, you don't necessarily need to do the captioning, because the AI model is smart enough to understand that you're trying to train a new person. However, if you're training a style or a concept or an object, this step is crucial, because otherwise the model will have a hard time understanding what you're trying to train. And even if you don't have to do it on a person, I still highly recommend to do it, because it will make the model more flexible and just better, especially because it doesn't really take a lot of time. And that is because we're going to be automating half of it thanks to a Koya SS tool, because if you go to utilities and then under captioning you click on blip captioning, it will actually do half of the work for you. By using an AI model called Blip, it's gonna analyze every single image in your folder and then automatically describe what's inside. And to use this is very simple. You're just gonna click on this little icon to find your folder images. So here you're gonna leave the caption file extension at .txt. You're just gonna leave it by default. But there is one thing that we need to add, and that is a prefix for the Blip caption. And basically what we want to put here is the name of our character that we're trying to train. But remember, we're not trying to train Millie Alcock, we're trying to train Sasha Loss. So basically here for the prefix, I'm simply gonna write the name of the character that we're trying to train. And in our case, it's Sasha Loss. And then for the other parameters, you can just leave them by default. And then click on caption image. So then it's gonna load the blip model and then caption our image. And now if we take a look at our folder, you will see that each one of our image has now a corresponding text file. And now if we open it, you see that inside we have a description of our image. So if we take a look at our first image, you basically see Millie Alcock in her Renera outfit in the House of Dragon series. And for the caption, we got Sasha Loss, a woman in a red dress with a necklace and earrings, which is already a pretty good base. However, we could probably make it better and put something like for example, Sasha Loss, a woman in a medieval red dress with white hair and necklace and earrings. As you can see, all we have to do is just describe the image in the most precise way possible. And basically, you're gonna do that for each and every caption. Basically, you're gonna describe the character, what she's she's wearing, what accessories she has, maybe even the background if needed, and your goal is just to make the caption more accurate so that the AI model understands perfectly what the image is all about. Simple as that. And so when you're done, when you finish captioning every image, you're gonna select all of your captions, copy them, and then you're gonna go inside the folder that we created previously with all of our new folder structure. You're gonna go inside the image folder, D20/woman, and then you're gonna paste those captions right here. This way, with the Koya SS will have access to this folder, it will not only see the images of the character that you're trying to train, but also the caption for each image. Okay, so now that we prepared our dataset, it is time to look at the training parameters. Now again, hopefully if you are a Patreon supporters and you have access to the configuration files, you are basically done. Everything is already done for you. All you need to do is just scroll down and click on Start Training. However, I will still explain a few parameters so that you know what you need to change depending on what you want to train. And here we're gonna start with train batch size, epoch, and save every n epochs. Now basically batch size is the amount of images that are processed all at once. And the bigger the number, the more VRAM it's gonna use, but the faster the training will be done. Now when it comes to epoch and save every n epochs, epoch basically means a cycle of training. Remember when here we inputted 20 for the repeats? This is basically the amount of steps per image. So if you have 10 images, it will basically be equal to 200 steps. So if for epoch you put 1 here, this will basically be equal to 1 cycle of training. If for epoch you put something like 5, it will be equal to 1000 steps, or 5 cycles of training. Now technically you don't even need to use epoch, because this is basically just multiplying this number, so if you want like, I don't know, like 2000 steps of training, you could just input 2000 here, and then input 1 here, and that's it. However, if you do that, you will not be able to understand when your model is undertrained or overtrained, which is why we divide the entire training into several cycles, or what we call epochs. And that is thanks to this little option right here that allows us to save every n epochs. Because here, let's say that we have 20 repeats and then 10 epochs, and that we save every epoch. If we have 10 images and then multiply them by 20 steps each, then we'll multiply that by 10 cycles of training. We then get 2000 steps of training, which is the equivalent of 10 cycles, where in the end, we should have 10 saved models, which will make determining which model is the best very easy. Now the reason why batch size and epoch are all connected is because again the higher the batch size, the more the total steps are gonna be divided. So if you input 9 for the batch size, you're gonna have 2000 steps divided by 9, which will be equal to 222 steps, which will make the training much faster, but again use way more VRAM. Now a lot of people online will tell you to not use a higher batch size when you're trying to train a character, because for some reason it will make the image look blurry, but in reality is not exactly true. What a higher batch size will basically do is create a smoother transition between models. Like for example, you see here that this is a model trained on Billie Eilish, trained with batch size of 1, and you can see that there is a stark difference between every model. Like every model looks very different compared to one another. However, here you have a model of Billie Eilish trained with a batch size of 5. And you can see that the transition between all the models are way smoother, which creates a model that is more flexible, meaning that you can easily add a style to the model compared to a model that is trained on a batch size of 1. Which is why when you're trying to train a style, for example, it is better to have the batch size as high as possible to have a very flexible model. And it's also very useful if you're training with a very large dataset, because if you put the batch size at 1, the training will last forever. However, no worries, even if you use batch size of 1, the only difference is that you will just choose another model in the epoch training, compared to a model trained with a batch size of 5. Now don't worry if you don't understand everything, I will show you later in the video how to choose the best model, so that it's not undertrained or overtrained. But basically here my advice, if you're trying to train a character like a real person, I recommend keeping the batch size at 1, which will make the training a little bit slower, but for most people who have a low GPU with a low VRAM, this is probably the best choice. And if you're trying to train a style, for example, you may want to increase that batch size to something like 5. But again, no worries because I prepared the style preset for you to use. So again, you don't need to do anything. But yes, in our case, since we're training training a character like a real person, we're gonna input a batch size of 1. So then here for the mixed precision and safe precision, in my case I input BF16 for both because I have a 3090, but remember, if you don't have a 30,000 series graphics card or newer, you need to use FP16 instead. So then here the number of CPU threads per core and seed, you're not gonna touch anything, just leave them by default. Make sure that cache latents and cache latents to the disk are checked and that the caption extension is .txt, because this is the extension of our caption that we inputted previously, as you can see right here. So then we go to the learning rate. The learning rate. I spent a lot of time trying to understand what is the best learning rate for training. I trained over 30 models to see which one is the best. And my advice to you for the learning rate is to input a value between 0.0001 or 0.0003. Now the reason why I give such a wide range is that in the end it really doesn't matter. Yeah, that's right. Because with those learning rate and the amount of epoch that we input right here, after a while you will find the right model for you. Like for example, this model was trained with a learning rate of 0.0001, while this one was trained with a learning rate of 0.0003. And the only difference is that basically the higher the learning rate, the sooner you'll be finished with the model. So like for example, if I were to choose a model trained with a low learning rate, I would probably choose a model between 4 and 6 epoch, whereas if I was using a higher learning rate, I would probably choose a model created on the epoch 3 or 4. But the thing is that it really depends on each model. Some model you'll be finished earlier, and some model you'll be finished later. It really depends on the character right here. Okay, so max resolution. This is the resolution at which the images will be trained, and the default value for SDXL is 1024 by 1024. However, do not forget that the higher the resolution here, the more VRAM it's gonna use. So if you want to save on VRAM, instead of inputting the full resolution of 1024 by 1024, you can input a resolution of 768 by 768, which of course will not make as good model that if we were using the full resolution, but again it will definitely save on the amount of VRAM that your GPU uses. But obviously, if you can, definitely put this at a max resolution of 1024 by 1024. Oh, and by the way, if you also want to train the style, a max resolution of 768 by 768 is also good. But again, obviously a high resolution is always better. So then here you have an amazing option called Enable Buckets. Now this option is the reason why we don't need to crop our images, because it will basically take our images at face value the way they are and train them at high resolution instead. So definitely leave this option checked. So then here for the text encoder learning rate and the unit learning rate, you're gonna input the same as our learning rate right here. So if you have 0.003, you're gonna input the same here and here. And if you have 0001, you're gonna input again the same here and here. But obviously in our example, we use the learning rate of 0.003. So then here for the SDXL specific parameters, you're gonna check no alph VAE, and if you can check cache text encoder outputs, which will basically reduce the amount of GPU VRAM usage. But unfortunately as of right now, this option is a little broken. So until they fix it, do not use this parameter. So then you have the network rank and network alpha. Now basically the network rank is how much detail the model is gonna retain. But at the same time, the higher the number, the bigger the LoRa file is gonna be. Now a lot of people actually privilege having a very high network rank because they want to retain as much detail as possible, which is of course understandable. However, the difference between them is not that big. Like for example, this is an image of a Cillian Murphy model that weighs 160 megabytes, and the one on the right is the same model but made with a higher network rank and that weighs 1.7 gigabytes. And indeed you can see that there is a few differences between the images. The image created with the bigger model is definitely way more precise, has way more details, better colors. However, in practice, when you use something like high-res fix, you see that the differences slowly disappear. And unless you compare them side by side, you will never be able to say that one model is truly bad. They are both good. But it is true that the model with a higher network rank retains way more details. But once again, depending on the model, on the characters that you're trying to train, the differences can be pretty small. On the left, you have a model that weighs 1.7 gigabytes that is trained with a very high network rank, and the one on the right is a model that weighs 160 megabytes. And the differences between them is very small. And again, same right here. So in a way, it really depends on what you're trying to do. If your goal is to have a LoRa that is very small in size, you can definitely decrease that number. In the end, it's really not gonna impact that much the final quality of the generation. Now obviously, it is undeniable that the images created with a higher network rank look a a little bit better, they look sharper, they look crisper, with a little bit more contrast compared to the one created with a low network rank. But again, the difference in size is pretty huge. So if you want to have like the best quality possible and you don't care about the size of your LoRa, for the network rank, you're gonna input 256 and 1 for network alpha. But if you want to have a very small LoRa with very minimal loss and a file size of 160 megabytes, for the network rank, you're gonna input 32 and 16 for network alpha, which will still allow you to make an absolutely amazing LoRa. So really, this is not a deal breaker. However, again, keep in mind that the higher the number, the more VRAM your GPU is gonna use. Yes, I know, again. But in my case, since I have a powerful GPU and I want to have the best quality possible, I'm gonna leave that at 256 and 1 for network alpha. So then for the rest, you're gonna leave at 0 by default, then click on advanced, and then here the only thing that you need to select and change is select gradient checkpointing, X-formers for crush attention, and auto upscale bucket resolution. But I think that most of these parameters are already done by default. Now there are some people online that's gonna tell you that for the additional parameters, you need to input something like network underscore train underscore unit underscore only. This is apparently a special parameters for SDXL training that will only train the unit part of the model. However, when training out myself, I definitely did not see a lot of differences, and I would even say that it creates a worse model. Like the one on the top is a model created without the additional argument, and the one below is created with the additional argument to train unit only. And as you can see, it kinda looks a little bit worse. Now of course, it definitely depends on the images. On some image it kinda looks better, on some images it kinda looks worse. But in the end, I really did not notice a lot of differences on which model really looks the best. Because again, in the end, it doesn't really matter what you do. Even if you don't put this argument right here, you will still be able to train a perfectly good LoRa. So this additional parameters is really not needed. So once we are done with all of that, well, guess what? We are 100% done. That's right, because now all we need to do is just scroll down and click on Start Training. And the Koya SS will start the training of our model. And as you can see, in our case, we have 4,800 steps of training with only 12 images. In my case, 4,800 steps of training will take around 2 hours. Yes, I know, it's quite a lot, but in reality, you don't really need to wait that much, because the model that we're gonna be using is not the one at 10 epochs. The reason why we put 10 epochs right here is that we want to choose the best model possible. And I'm gonna show you later in the video. And as of right now, this entire training is taking around 20 gigabytes of VRAM. But do not forget that I am recording a video and I have also a bunch of applications running in the background. So for you, it will be probably around 19 gigabytes instead. But don't worry, even if you don't have a powerful GPU like a 3090, I have here a low VRAM preset that you can use that will basically knock down that VRAM requirement to around 12 gigabytes of VRAM. So in theory, you should be able to train a LoRa SDXL on around 12 gigabytes of VRAM. Now you just need to wait. However, you might be asking a question, and that is, well, that's great and all, but how do I know when something is finished? Because I don't really see any terminal window. And yes, it's true, and there is no terminal window, but there is something a little bit similar. Now, it's not as good as the real terminal window, but you're still gonna have the same information. And to see this, basically what you need to do is just go inside the logs folder, and then double click on the Koya ss.log. And you scroll down, you will see that the training has started, exactly as if this was your local computer. Now, because it is simply a log file, like it is just a text screen, it will not automatically update. So if you want to see the progress, each time you need to close the file and reopen it again. And yeah, I know it's a little annoying, but you're basically not gonna spend a lot of time looking at this log anyway. Because what's actually important is where your models are gonna be saved. Because now if you go to workspace, then go inside the folder we created and go inside models, this is where all the models saved every n epoch are gonna be saved. Now obviously I've already done the training before, so here I'm gonna show you the screen of a model that has finished training. As you can see, we have 10 different models. Because since we trained for 10 epochs, and we save every epoch, it will basically save 10 different models. So now the question is, how exactly do we choose the right model? Do I choose this one? Do I choose this one? Do I choose this one? How do I even know? Well, the only thing that we really need to do is generate a few images with each one of those models and then compare them side by side. And again, inside RodPod, with that template, it is done very easily. All you need to do is just select all of your models, right click, click cut, then go back, go inside inside the Stable Diffusion Web UI folder, inside models, then LoRa, and then you're gonna right click and paste all of those models right here. And yes, I know I already have a few models already present, but for you, you should only have 10 models right here. And then here, back in RunPod, you're gonna click on the very first link, which again, as I said, will open the automatic 1111 Stable Diffusion Web UI. Because now if you click on this little icon right here, and then click on LoRa, you will see here all of your LoRa files. So now what we need to do is input a prompt, because now we're gonna generate a bunch of images with each one of those models to compare them side by side to determine which model we need to choose. So like for example, I'm gonna input something like anime illustration portrait of Sasha Lush woman, forest with lake in the background, high quality, beautiful face, action pose, etc, etc. And here do not forget to use the instance prompt and our class prompt. So if you remember correctly, this was Sasha Nuss and woman for the class prompt. You need to input those words to trigger the LoRa files. And also do not forget to input a fixed seed and a high resolution. So in my case, I choose 1024 by 1320. So now what I recommend you to do is you're gonna click on each one of those LoRas, one after the other. And I'm gonna explain why. So as you can see, here I have clicked on each one of those LoRas. They are now present inside the prompt, so I'm gonna close this window. And now I'm gonna select all of those LoRas, Ctrl-C to copy it, and then I'm gonna delete everything except the very first one. And now if I click on script, then XYZ plot. For the X type, I'm gonna choose prompt SR, and then here for the X values, I'm gonna paste the name of all the LoRas I copied previously. And then after each and every LoRa, I'm gonna input a comma. So comma here, then comma here, here, etc, etc. Now what this will do, and why this is so cool, is that this prompt SR script will basically replace the first value that you see right here inside your prompt with all the next values. So basically, if you input the first value right here, it should be the same in your prompt, so it's gonna look for that value in the prompt and then replace it with all the next values to generate a sequence of images, and everything will be done automatically. So now for example, if I click on generate, it will start generating a bunch of images with every single LoRa, where in the end you should have something like this. Now I've already copied and pasted this image before because I've already done the training, I've already done the generation, but then in the end you should have this entire sequence with each and every image generated with a different LoRa. And now your goal is to determine which model is the best. Which model do you need to choose? And the problem is that a lot of people actually choose the wrong model. Because now let me ask you a question. If you look something like this, right? Which one would you actually choose? You will probably choose this one or this one, right? Because it looked the most like the character, right? Well, this is actually wrong. Because those models that you see right here are already overtrained. So the thing with LoRa training, or with any training in general, your goal is to basically balance between flexibility and accuracy. Like basically accuracy is how accurate our image looks like the character that we try to train, and flexibility is how good it is at applying a different style. And your goal is to find the right balance between all of those models, which can be very, very tricky, because most people, when they see those images, they would usually choose a model that is more accurate than flexible. And I mean, in a way, there is nothing wrong with that. It's really up to you which one you really prefer. If you prefer a more photorealistic model, you should definitely choose a model that has more training. But if you are like me and you prefer a more flexible model, you would probably choose a model with a little bit less training. So like for example, if I were to choose a model right here from all of those 10 models, I would probably choose the model number 3, which not only still look like our character, but still retain that style. Because do not forget that our base prompt was an anime illustration portrait. And if you're trying to generate an anime illustration portrait and your image looks like a photo, you have not chosen the right LoRa. I mean, at least in my opinion. Now, there are some people that are gonna say, but look at this model. This doesn't look as good as the one right here, for example. How can you choose this model over this one right here? Well, again, first, it is just a matter of personal choice. And second of all, there is a way to make the final image look even better without compromising the flexibility. And that is by using high-res fix. This is an absolutely amazing option that will make your final image made with LoRa even better. So like for example, in our case, I chose the third model. So here, instead of 1, I'm gonna input 3. Then for the script, I'm gonna choose none. I only want to generate images with that model. I'm gonna keep the exact same seed, the exact same parameters, the exact same prompt. I'm just gonna enable high-res fix. For the upscaler, I'm gonna input ESR again 4x. For the iris step, I'm gonna choose 30. For the denoising strength, I'm gonna input 0.4 and then upscale by around 1.5. And I'm gonna try with those parameters first to see if the final image looks better. So now if I click on generate, and this is our final image. And as you can see, not only we still retain the accuracy of the model because it still looks like Millie Alcock, but at the same time we still retain that absolutely amazing style that looks like a painting. So when you go and compare that image to models that are more trained, you can see that there is a huge difference in quality. And again, in my opinion, if I had to choose a model, this would probably be this one. It is very flexible and still retain the accuracy of the character, which as you can see, can create some absolutely beautiful images. I mean, those images looks absolutely gorgeous and you can really do anything you want. The sky is the limit, because if you try to do the same thing with more trained models, you will never be able to achieve this level of quality and flexibility. So yeah, in my opinion, be careful of one model you choose and prefer flexibility over accuracy, because accuracy can always be made better using the iris fix option. Oh, and also if you want to save that image as a LoRa preview, all you need to do is just click here, select the LoRa model, click on this little icon, then scroll down and click on replace preview. And now as you can see, we have this image preview for our LoRa model, which looks really cool. And then now once you're done and you want to save the model onto your computer, all you need to do is just right click and then click on download. And now you are done. Now of course, if you really want to find the right model for you, you should definitely generate a few more images using the same method I showed you so that you can find the best model for you. And there you go. Now you should know everything that there is to know